Progress Check 5.1 for GCSE Maths, Statistics. Question number 1. The pictogram shows the number of DVDs borrowed from a shop on Monday and Tuesday. How many DVDs were borrowed on Tuesday? So we're looking at Tuesday. We have the key here, which shows that this shape represents 10 DVDs. So this is going to be 10, 20, this is half, so it's going to be 5. So 25 in total. In question number 2, we have the line chart shows the number of goals scored by a football team in the last 16 games. How many goals did they score altogether? So there are 16 games in total. We have the number of goals scored, so 0 goals were scored twice. So we have first match 0. It could be the first match or maybe the second, third, but I'm just going to put them in order like this. So we have another match with 0 goals, and then we have 5 matches with just 1 goal. So 1, 2, 3, 4, 5. Then we have 4 matches with 2 goals. So we have 3 matches with 3 goals and 2 matches with 4 goals. So the number of goals that they scored altogether would be worked out by adding all of these numbers. So we have 5 lots of 1, which is 5, and 4 lots of 2, which is 8, 3 lots of 3, which is 9, and 2 lots of 4, which is 8. So we'll add these up. 8 and 8 is 16, 9 and 5 is 14, so that makes 30. So there were 30 goals altogether. What was the median number of goals scored? So the way I've laid it out in here, with all the number of goals in order, it's going to be easy for me to work this out. So I'm going to cross out both sides. So we have 2 and a 2, which is 4. Half of 4 is 2, so that gives us an answer of 2. So the median number of goals is 2. Question number 3. Billy has been carrying out a survey. He asked 100 people the type of water they like to drink, still, sparkling or both. Here are part of the results. So we have still, sparkling, both, and then we have male, female and total. How many females drink only still water? So we're looking at still, so it's this number here that we want to find out. So what are we going to do to figure out what this is? Because we don't know this number here, we can't work out this one. So we'll do this first. We've got 53. What do we need to add to 53 to give us 100? And that is 47. So we have 47 females in total. We've taken out 20 and the 10. So 47, take away 30, leaves us with 17. So the number of females who drink still water only is 17. Question number 4. This pie chart shows information about how the learners in a class travel to college. what percentage of the whole class walks to college? So we have walk, which is half, so that is this one here. As you can see, it's half of the circle, so that is 50%. There are 28 learners in class, so in total that is 28 learners. How many of them travelled by bus or car? So bus or car, both together. This is 25%, because this is a right angle, so it's a quarter, and then we have the half already, so this is 50%, this is 25%, so these two combined, bus and car, will be 25%, so a quarter. So in other words, we're looking at finding a quarter of 28, which is 7. Question number 5. Henry reads 8 books. For each book he recorded the number of pages and the time it took to read it. The scatter graph shows information about his results. Henry reads another book. The book has 150 pages. So what we need to find is how long it takes Henry to read it. So estimating the time it takes Henry to read it. Now, because this is a scatter graph and we want to estimate an answer, we're going to have to draw a line of best fit. So you'd use a ruler for that, to draw a straight line that goes through the points, trying to keep an equal distance between the points. So I'm going to try and do that now. So this is about here. There is no exact answer to this. We're only estimating. So we're talking about 150 pages. So that's the number of pages. 150 is here. So I'm going to go up and see where this meets the line. And then draw a horizontal line to see where that goes. So this is about 7 hours. So in between 6 and 8, we've got 7 hours. Question number 6. The number of pens in each pupil's pencil case in a classroom has been counted. The results are displayed in a table. So we have number of pens and number of pupils. So we need to work out the mean number of pens. As we know, the mean is worked out by adding them all up and then dividing by how many there are. So in terms of the number of pens, we have 4 pupils who have 0 pens each. So for those, there's going to be 0 pens. We have 6 pupils with 1 pen each, so it's going to be 6 pens in total for them. Then we have 7 pupils that have 2 pens each, so that is 14 pens. And we have 5 pupils with 3 pens each, so that is 15. And we have 3 pupils that have 4 pens each, so that is 12. And 1 pupil has 5 pens, so that is 5. So to work out the number of pens in total, we have 6 and 4, 10, 15, 20, 22. So 2 down and 2 carried over, so 2, 3, 4, 5. So there are 52 pens in total. Now that is the number of pens, but we've got to divide it by the number of pupils so that we can work out on average how many pens per pupil. So now we need to look at the number of pupils. We have 6 and 4, which is 10. we have 7 and 3, which is 10 again, and 5 and 1, which is 6. So 10 and 10, 20, and 6 is 26. So 52 divided by 26. These are nice and easy numbers to work with. So this tells us that there are 2 pens per pupil. That is on average. Now we'll need to work out the median number of pens in a pencil case. So we could do this by just listing the number of pens. So we'd do 0, 0, 0, 0, because 4 of the pupils have 0 pens each, and then we'd do 6 lots of 1. So we could do this, but it's going to take a bit of time. So instead I'll look at another way using the table. As you can see, we have this list of numbers that go 0, 6, 14, so representing the number of pens. Now what I'm going to do is I'm going to add on the next number to the previous one. So I'll start with 0, and we're going to add then 6 to it, then add 14, so that makes it 20, and to the 20 I'm going to add the 15, so that makes it 35, add 12, so that makes it 47, and then we come to 52 cumulative. So what we're going to do now is we're going to go halfway through this. We know there are 52 pens in total, so halfway through it's going to be between 26 and 27. So there is 20 here, but we're looking for more. 26, so it's going to be within this. So both 26 and 27 go within this 35 in here, because they are lower than 35 but higher than 20. So we're looking at this row. So the number of pens, the median number of pens is 3. Now we've got to work out the modal number of pens in a pencil case. So we're looking at the most common number of pens. So that is, the more pupils have had that number, that's what we're looking to put in here. So looking at the number of pupils, the highest is 7, so the modal number of pens is 2, because 7 pupils had 2 pens each. Now we've got to work out the range of the number of pens in a pencil case. So what's the highest number of pens that the pupils could have? That was 5, and the lowest is 0. So 5 take away 0 equals 5, and that is the range. In question number 7, we have Isla recorded the time in minutes that her bus was late over 50 days. Information about these times is shown in the table. So we have time in minutes and frequency, which means how many times the bus was late. Between 0 and 6 minutes, between 6 and 12, 12 and 18, 18 and 24, and 24 and 30. So we've got to estimate the mean time in minutes of her bus being late. Now the reason why we estimate is because we cannot be sure how many minutes exactly, since we're saying a range of values between 0 and 6. So for this reason, we're going to find the mid value. What is that number that is right halfway between 0 and 6, and multiplied by the frequency? So between 0 and 6 there is 3, between 6 and 12 9, between 12 and 18 is 15, between 18 and 24 is 21, between 24 and 30 is 27. So what we're going to do now is multiply these across. So we have 42, 45, 300, and then 21 times 6, and 27 times 5. So we'll add all of these together. And this is 648 minutes in total, which we'll need to divide by the frequency. So we have 14 and 6, which makes 20. We have 5 and 5, which makes 10. So 20 and 20 is 40, and 10 is 50. So that's how many times? 50 times. So we'll go 648 divided by 50. Which gives us 12.96 minutes. The stem and leaf diagram below shows information about the times in minutes it takes a group of people to eat their breakfast. So we have this question: how many people are there in the group? So we've got the 0, 1, 2 and 3, which is the first digit of the number. So this is 05, which means just 5 minutes. And this is 07, so 7 minutes, 09, 9 minutes. This is 10, and then 10, 15, 18, 18, 20, 22, 23, 25, 27, 32, and 35. So the actual values can be counted here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 values, 15 people in the group. Progress check 5.2, probability, for GCSE Maths Foundation. Question number 1. In a box there are 24 cubes. 12 are yellow, 3 are blue and 9 are white. Without looking in the bag, a cube is taken out. So we have this number line here. So this represents 24 in total. That would be here 1, equal to 1. On the probability scale above, drag each colour to the position that represents the probability of picking that colour from the bag. So 12 are yellow. 12 is half of 24, so that's going to be going here. 3 are blue. 3 out of 24 is the same as 1/8. So I'm going to split this into half and this into half and half again here. So this would be 1/8, which is the blue colour. Then we have 9 white. So if this is 3, this is 6, so there comes the white colour. So this is 3/8. In question number 2 we have: how many possible outcomes are there if a coin is flipped and the 6-sided dice is rolled? Here is an example of an outcome, H1. So for the coin we have either H or T, so heads or tails, and we have 6-sided dice, which is either 1, 2, 3, 4, 5 or 6. So if I get heads, then I might have a 1. I could have heads and 2, or heads and 3, heads and 4, heads and 5, or heads and 6. If I get tail, I can get tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6. So these are the possible outcomes. The question is, how many of them? So counting them, 6 and 6 is 12. So the answer should be 12. In the third question we have, there are 9 pens, 8 pencils and 6 rulers in a stationery box. A stationery item is taken out of the box. What is the probability that the picked item is a pencil? So first of all, there is the pencils. So we have 8 pencils out of the total. What is the total? We have 9 and 8 and 6. So that is 23. So 8 out of 23. This is the fraction. You could write it as a decimal. So 8 divided by 23, which is 0.35, rounded to 2 decimal places. Or you could write 35% as well. So any of these versions is correct. The probability that the football team will win their next game is 0.74. The probability that they will lose is 0.15. What is the probability the game will be a draw? So the 3 possibilities are either win, lose, or draw. And we know that they should add up to 1. So we already have 0.74 and 0.15. So we'll take it away from 1. And it gives us 0.11. So this is the probability the game will be a draw. On the school dinner menu, there is only ever one of 4 options. Some of the options are more likely to be on the menu than others. The table shows the options available on any day, together with 3 of the probabilities. Work out the probability of the dinner options being fish. So we have curry 0.36, sausages 0.41, fish, which is blank and we need to fill in, and casserole, which is 0.09. So we know that all of these 4 options should add up to 1. So I'm going to add these 3 probabilities that I have. So 0.36 plus 0.41 and 0.09. So all together this gives me 0.86. So I'm going to take this away from 1. And it gives me 0.14. So the probability of the dinner option being fish is 0.14. In the next question we have, on a biased dice, the probability of getting a 3 is 0.5. The dice is rolled 350 times. So work out an estimate for the number of times the dice will land on a 3. 0.5 represents half. So half the time you'd get a 3. This means that if you roll this, theoretically, if you rolled the dice 350 times, half of the times you'd get a 3. So you could do this as 0.5 times 350, or you could do 350 divided by 2, which is the same thing, so that gives us 175. And that is an estimate for the number of times the dice will land on a 3. Question number 7. 2 dice are rolled and their scores are added together like shown in the examples below. What is the probability of getting a result that is an odd number? Write your answer as a fraction in its simplest form. So we have the first dice and the second dice. So the options are 1, 2, 3, 4, 5, 6, because this is what you get when you roll dice. These are the possible numbers. And same thing on the other side. Now what we're doing with the scores is that we're adding them. So if you get a 1 with the first dice and a 1 with the second dice, you add them together, so that gives you 2. And same thing, if you get 2 and a 1, that gives us 3. And then 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So the question is, what's the probability of getting a result that is an odd number? So we're looking at the odd numbers in here. Change the colour. So what do we have as odd? 3, 5, 7, 3, 5, 7, 5, 7, 9. You can see the pattern in here, so it's basically half of them. But we'll continue with this. So how many numbers do we have in total? That is 6 times 6, that is 36. So half of them, so 18 out of 36 are odd. So the probability is half, or 0.5, or 50%. Question number 8. There are 31 students who study languages. All 31 study at least one of Spanish, French or German. So all of these will be within the circles. No numbers outside of the circles, since all of the 31 study at least one of the languages. 4 study all 3 languages. So this is the area that is overlapping for all 3 of them. So we'll put 4 in there. Then we have 9 who study Spanish and French. So the area that is overlapping is this one in here. So we'll put 9 in there. 7 study French and German. So that 7 should go in there. 6 study Spanish and German. 7 study only French, and 5 study only German. So we've completed the Venn diagram. Now, the sort of questions that you could get that link to this would be to work out the probability of a student studying all 3 of the languages, for example, which is this one here, the 4. So that the way you'd work that out would be 4 out of the total, which is 31. So 4 divided by 31. Or you could have a question such as work out the probability of a student who studies French and Spanish, or studies 2 languages. So that would be looking at these in here, adding them up out of the total. So there are a range of questions that you could be asked in here, although this specific one is just asking us to fill in the Venn diagram. Question number 9. There are 150 students who are studying either maths or English. 83 of them are studying maths. So we can work out how many are studying English through that. So 150, take away 83, 67. 12 of those who studied maths have passed the exam already. So we can work out how many have not passed the exam already. So we have 83, take away 12, which is 71. We can see that this is maths, and this is English, and this is passed, not passed. We have passed, not passed, based on the information we're given above. And we know that 12 have passed the exam, the English exam as well. So how many have not passed? So we go 67, take away the 12, gives us 55. Question is, how many students who are studying English have not passed the exam yet? And so we go through English, not passed, that is 55. Question 12 is more of a statistics question rather than probability, but we've had to move this to this progress check due to the specific number of marks that we needed to have for one progress check. So we've got to write next to these pieces of data whether they are discrete or continuous. What is the difference between them two? With discrete, it can only be specific values, like the size of clothes, for example, or size of shoes. They can only have specific values. So it can be size 6, 8, 10, 12, 14, 16, 18, and so on for clothes. You can't have size 11, or 11.2, or 11.5. Or when it comes to shoes, for example, you only have certain values as well. So you can't have 6.1 or 6.2 or 6.345. So size of clothes is discrete. And so is the number of pens, because you can't have 2.3 pens. Whereas the height of a person is continuous, because you could have somebody being 182.35 centimeters tall, or 1.7123 meters tall. So it's a range of values, not exactly specific. Same thing with the weight of an apple. So it can be 85 grams, it can be 86.12 grams, so a range of values.